All right, find the region. No, find the volume. No, find the volume of the solid generated when the region between the graphs of y equals x squared plus 2 and y equals x plus 1 is revolved about the line y equals negative 1. All right, so we're gonna take a look at this and we're gonna see what to do. All right. What? Find the volume of the solid generated when the region between those graphs is revolved about this line. Okay, draw a picture. It's the first step. Draw a picture. That's how it goes. All right, let's draw the picture. Y equals x squared plus 2. That is just the parabola. That's just the parabola. Shift it up twice. So that's just like that. That's very nice. No, that's not that nice. All right, that's the parabola. And then y equals x plus 1. That's just the line. Y equals x plus 1. Shift it up once. There you go. Settle down from 0 to 2. Let's just say that. Now this is from 0 to 1. From 0 to 1. From 0 to 1. Okay. From 0 to 1. Okay. So we're taking this region here and we are going to revolve it. What? Not about the x-axis, but about the line y equal. I'm going to dot that. I'm going to dot it. And we're going to revolve it about that. This is y equals negative 1. Okay, so we think about this stuff. We think about it. We think about it like this, okay? You see where you go to look at this. Look at this. You don't have to draw this, but look. If we were to take just this part and revolve it around, it would create this little solid disc thing with like a beveled edge. Ooh, that's a good one. I paused it. I meant to undo it. Whoops. So that would make some kind of solid that looked like this, and it would be all filled in. It's like a little tortilla holder. Why? I don't know. But it's terrible drawing. It would be a full solid disc, right? And we want to take out this center part, which is like a little saucepan, like a little flan. Oh, you turn it sideways, it's like flan. What? It's like we want to take the whole thing minus that inside piece. So we're going to take the volume here and subtract away the volume that you get from the other equation. It's the same steps, except for now we have to find two different radii. So let's see. Let's just start this. The first integral that I'm going to think about, I mean, you could write this as one integral, but I'm going to write it as 2 just because I think it makes more sense to my brain. The first integral is I'm going to figure out this radius from this curved edge to the line of revolution. And that distance is just whatever my function is, y equals x squared plus 2. So that distance will be, let me zoom in. I don't need the y. X squared plus 2. And then minus, because I'm finding the distance, I subtract, minus the smaller one, and that's negative 1. I minus a negative. Oh, that's very interesting. And then that's the radius of that large, the large solid, and then like later on we're gonna subtract away the volume that we get from the inside solid. But anyway, so we'll square that in terms of x, dx, and is we said from 0 to 1. And don't forget the pi, sweetheart. All right. And yeah, that's the area of that large outside area. The whole thing without anything missing. We want a disc with like a hole in it. So we're going to take out this area and get, this volume by calculating the radius, which would be this function minus negative 1. Right? You're just taking that distance. That distance is, well, this function was y equals x. I should say y equals x plus 1 minus negative 1. right? Shoot, hold on. That distance is just x plus 1 minus negative 1. So I'm going to write the integral for that. So I'm going to subtract off the integral with a pi, 0 to 1, of x plus 1 minus negative 1 dx. I'm going to square this because it's my radius, pi r squared, and then I'll calculate stuff. So this becomes x squared plus 3 quantity squared, yeah? Which, if I FOIL it all out, I get x to the 4th plus 6x squared plus 9. And then I can take the antiderivative and do all that other cool stuff. So that's what I get if I do the antiderivative. And then I will do the same for the green. I will also do it in green. So I get x plus 2 quantity squared. And then the integral from 0 to 1 with the pi outside. And it's minus. And then I take the antiderivative, and now I'm ready to evaluate some stuff. Okay. Yeah, that was pretty quick. What do I do now? Well, I put the 1 in there. What do I get? I just get the 1/5 plus 2 plus 9. This is all times pi. I would subtract the 0, but all of them turn to 0, so I don't need to do that. Minus pi times 1/3. Ooh. Plus 2 plus 4. So I will simplify and get the answer, and then I'll be done with the video. After simplifying, you should get 73 over 15, which is a pi, and that is the volume. So, the only difference for this stuff is when you have a distance that isn't the x-axis, you just have to subtract off. Instead of subtracting 0, you subtract -1. It's really not different at all. Go look at the assignment. Please. I'm done.